Hello everyone, welcome to this video. Now let's move on to more questions in this video. So we have completed question 1 to 10 from exercise 9.1. Now let's look at question 11. Here they are saying that we need to write down the first 5 terms of each of the given sequence, and then from those terms we need to obtain the corresponding series, right? So in the first question here, that means question number 11, we are given a1 as equal to 3 and an is given in terms of an minus 1 here whenever n is greater than 1. So you see, in most of the cases this condition is very important, because you first of all have to check it for each and every term. So let's see how we can perform this. The first term obviously is for n is equal to 1, which is a1, which is already given to us as 3. For the next term, we need to substitute n is equal to 2 in our general term, so that we would have a2 is equal to 3 times of a1 plus 2. Now what we have to do, we have to substitute the value of a1 from above. So we will put a1 is equal to 3 into this, so that we would have a2 is equal to 3 times of 3 plus 2. So our a2 would be equal to, it is 9 plus 2, which is 11, right? For the third term here, we need to substitute n is equal to 3, so that we would have a3 is equal to 3 times of a2 plus 2, right? And what is the value of a2? We know a2's value is 11, so that our a3 would be 3 times of 11 plus 2. So it is 33 plus 2, which is 35. Next we need to find out the value of a4. For a4 we need to substitute n is equal to 4, so that a4 would become 3 times of a3 plus 2, right? We are substituting the value here. So when you substitute n is equal to 4, this would become 4 minus 1, which is, it would become 3, right? So this is how I am doing it. So that you already know the value of a3, it is 35, right? So using it here, 3 into 35 plus 2. So how much is that? It is 105 plus 2, which is 107, right? This is the fourth term with us. For the fifth term, we need to substitute n is equal to 5. So we need to put the value a5 here. We need to put n is equal to 5 in the general term, so that we have 3 times of a4 plus 2. So this gives us a5, that is equal to 3 times of, now a4 is 107, so 3 times of 107 plus 2. Now we need to solve this one, right? So we have 321 plus 2, which is 323, right? So our answer here is 323. So now here in the question we have the terms as, the terms of sequence are, the first 5 terms of sequence, they are, the first term you know is 3, the second term is 11, right? The third term is 35, so we have 35 here. Next term is 107, and the next term is 323. So therefore the corresponding series, what would it be? In you remember when we write series, what we do in sequence, we just replace the given comma with a plus sign. So we have 3 plus 11 plus 35 plus 107 plus 323 and plus dot 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 dot, because there are more terms present in this particular sequence. And moreover, actually you do not need to solve this one and write a single number. You just have to leave the question here, and that would be your answer. This would be your series, and not whatever is the sum of this. Understood? So here this is how we solve this question. For the next question here, we are given the first term here, right? So for the solution of question 12, we need to calculate again the first 5 terms. So here the first term is given to be minus 1, and this is the general term that is given to us. Now notice that n is given to be greater than equal to 2. So that means this term is valid whenever we have the values of n as equal to 2, 3, 4, 5, 6 and so on, right? So therefore we may use this term whenever n is 2, 3, 4, 5, 6 and so on. It is greater than or equal to 2. So that means for a2 we can put n is equal to 2 in the general term, which is an is equal to an minus 1 divided by n. So that we would have a2 is equal to a1 divided by the value of n is 2, right? So how much is a1? It is minus 1. So the second term here is minus 1 by 2. Next we need to substitute n is equal to 3 in the general term. So we need to put it in an minus 1 divided by n. So that here we would have a3 as equal to a2 divided by 3. So how much is a2? a2 is minus 1 by 2 divided by 3. So the answer is minus 1 by 6. Next we need to substitute n is equal to 4 in our general term. An is equal to an minus 1 upon n. So that our a4 would be a3 divided by 4. What is the value of a3? It is minus 1 by 6 divided by 4. So your answer would be minus 1 by 4, 24, correct? Okay, and the last term n is equal to 5 is obtained when we substitute n is equal to 5 in the general term. So that in this case a5 would become a4 divided by 5. What is the value of a4? It is minus 1 by 24. So minus 1 by 24 divided by 5, it would be equal to 1 divided by 24 into 5. Now how much is that? We just have to multiply them both. So it is 120, right? So these are the first 5 values of our given sequence, right? So what would be the series? The corresponding series would be obtained when we write all the terms in the addition form, right? The corresponding series would be writing a1, which is minus 1, right, plus the first term plus the second term plus the third term plus the fourth term plus the fifth term and plus dot dot dot. So first term is minus 1, second term is minus 1 by 2, third term is minus 1 by 6, fourth term is minus 1 by 24, fifth term is minus 1 by 20, right, plus dot 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 dot, and this is our answer. Now notice that we surely have to put brackets here because we have negative terms, otherwise this plus and minus would become double signs here, right, in each of the terms. So that is it for this question, right? And that is it for this video. Thank you for watching.